Hello, everyone. I hope your day is starting off very good. Welcome. Thank you for coming to our event. And my talk today is entitled The Developer's Dream. This is a title that was made up by Jorge. And it comes from the notion that what we started in the beginning to try and do with Liferay was to bring, like Amiro said, to bring the joy back to building applications on Liferay, to building extensions and to working with it, as in our day-to-day. So if you want to make a developer's dream come true, you can't forget any of the necessary elements that are involved with developing software. There's a full life cycle involved in doing this. You need to write your code. You need to compile your code. You want to assemble your code. You need to test it. You need to execute it. And eventually, you need to debug it. If any one of these elements is flawed or missing from your development experience, then you have major problems. And this is actually one of the reasons why Java consistently ranks up in the most used languages, because the life cycle, the tooling life cycle is very well equipped, unlike other languages which tend to often be lacking in one or many of these different areas. So the next thing that we want to do in order to make the dream come true is to make it easy. It shouldn't be overcomplicated to do what we need to do. You want to focus on your business logic. You don't want to be trapped with too much baggage or too much complexity before you even start, because then frustration's gonna set in, and frustration moves to anger and disappointment, and that's not what we want. That's definitely not what you're dreaming of. The other thing is that we want it to be familiar. So we're just, in our case, we're just going to use a plain old jar for the basic unit of modularity. As Jorge and Tim have talked about previously, the goal is modularity. And we need to have a language familiar with that, familiar to us to work with, and the jar is the fundamental unit that we're going to use to build on. And secondly, after it's easy, we need our modules to be concise and easy to understand. So when we look at a module, when we look at the pieces of business logic that we're writing, we want to have less boilerplate code there. We don't want to have all these descriptors that are very hard to interpret or just duplicate information or are too far away from the knowledge, separating the knowledge from the application. We want to bring these things together. We want to simplify. We want to make it less. We want to write less lines to achieve more work. So the other aspect here that I wanted to mention is that it's fairly common in today's development world that a developer doesn't stay on a given project for very long. It's quite often that we have to transfer maintenance of some components that we build from developer to developer. And this is just because our companies grow, people move on, and so what we're really shooting for is easy transfer of knowledge. If you have very complicated software, if you have very complicated libraries, the transfer of this information becomes very, very difficult. And we've actually experienced this inside of Liferay as we've grown as a company, as we've gained more developers, as developers have moved on, and we've lost knowledge. It becomes evident that the more complex things are, the harder and the more loss of knowledge that you have, and the harder it is for new developers to on-ramp. the tinier the responsibility or the unit of understanding is, the easier it is to, one, have good tests, have good documentation, and to be able to easily fit inside a developer's brain. So, and that lastly, again, it's about decoupling. And how do you decouple? You decouple by having contracts. And when you have these contracts, the little icon I have here is actually a couple in love, right? You would think the decoupling is taking away the love, but it's actually increasing the love by having a better communication channel. So by having a contract, there's less deep knowledge about what the other side of the contract is going to do in order to implement it. It means substitutability. So we can replace either side of the contract with some other implementation. And then because the contract is enforced, that still works. And ultimately, it means sanity. But contracts are hard if you don't put versioning to them. Because then, if you have a contract and you don't have a version, evolution isn't practically impossible. Because there's no account for some other later version of a contract, and then you can't evolve. And so semantic versioning, as was mentioned already, is critical for sane software evolution. And finally, services. And I have a line here, implied risk. So when we build traditional monolithic applications, we very often take things for granted. We have code like Tim showed of a cast of an implementation class to some type and then calling an inner method. And this is dangerous. Or just doing a class 4 name or using a factory to load an implementation. The closer that we get to knowing the deep details about some implementation, the more we're putting ourselves at risk. By leveraging services, as you'll see throughout the rest of DEVCON, we're going to talk about services more and more. Jorge was calling it microservices. It's the same concept. The developer now has the onus to understand that there's a risk in things that they're going to depend on. And so that's like a part of the value chain of building a modular system. There is a certain amount of risk involved, but now you just have to acknowledge it. And it may seem like a scary notion to have to deal with now, but it actually is quite liberating when you see the system, as Tim mentioned, self-assemble itself by validating all this dependency chain. And it's very simple to do, as Jorge showed with the little annotations on the classes to do the wiring dynamically. But it's still there. The developer now has the onus to understand the risks of the dependencies. And this makes for much, much better software. And if you've followed the last couple of years, the Reactive software manifesto, the Reactive programming model, I firmly believe that the Reactive programming model, as a cornerstone, has services. Services are a cornerstone of the model because it's difficult to have a system react to the conditions and to its environment if it can't dynamically alter its state. And so OSGi services can have this functionality built around them and transparent to the service itself. So like Jorge said, we're talking about in-VM services, but that doesn't necessarily That's not necessarily implied. It's just a fact at the start. But it's completely conceivable, and it's actually, there's already specifications implemented for it, that a service could suddenly move from in-VM to being remote, transparently for the system. The system would recognize no difference. And so this would allow the system to, repair itself, deal with excessive load, and basically to fulfill the requirements or the principles of a reactive system. So what are the elements of Liferay 7 extensions? So you've heard that the fundamental principle, the fundamental technology is OSGi. And yet, there's many pieces to the story that is OSGi. First of all, you have a framework. All of the modules for OSGi run inside of a framework, a runtime that ensures the contract and the lifecycle of the modules. And then on top of that, or within that, we have the use of different OSGi technologies inside of the framework. And here I have CMPN and EE, and those are basically two subtrees of the OSGi specifications, which we've pruned out certain valuable to us specifications and implementations, and put those together to build the environment that we wanted. And all of the implementations that we're using are all open source. Even the ones we're using from the community, from the various open source communities, and also the ones that we're building ourselves. Which is again, going back to what Jorge was talking about in his keynote, and Tim was talking about, it's about not reinventing the wheel, not rebuilding every piece of the system ourselves. Reuse systems and pieces that other people have built, because we can't do it all ourselves. And so the open source is definitely one way to achieve that. So getting down to the nitty-gritty. One of the most important technologies that Liferay is leveraging within OSGi, and it's probably the one that if you're going to get involved in developing extensions for Liferay 7, this is probably the single most important technology to understand. Fortunately, it's extremely simple to use. It's called declarative services, or DS for short. I've referenced here the chapter of the OSGi compendium that contains this specification. It's I highly recommend that you look at this specification. It's not very long. I think it's probably around 30 pages at most, including its Java doc. So it's a very important technology, and in fact, it should look very familiar to you if you know things like CDI or JSR 316, which is, I'm not sure if it's JSR 316, the injection framework. So declarative services is the component framework that Liferay uses to do all of the assembly of all of its microservices, as Jorge called them. And in my opinion, and there are other component frameworks, there are other dependency injection frameworks in OSGi, but in my opinion, declarative services should be your go-to, and you should only consider, or you should consider other injection frameworks only if there's something in declarative services that you can't do. So this should be your first choice, because it should do 80 to 90% of what you need. And if you were to look at the Liferay source code base, and we have many modules and lots of code there, and we're using DS for probably 98% of it. So the next important technology, or the next complication with a complex system like Liferay, is configuration of all of these modules. And it's very hard to get this right if you have to implement it on your own. Fortunately, we have another OSGi specification which we're leveraging, which is configuration admin. Again, the chapter reference here. And this is about configuration management. The very interesting aspect of OSGi services is that you can inject configuration into the services at any time. So services can evolve over their life. You can actually update them, and it's if you couple this configuration management with declarative services, it's very, very concise and very simple model. And as of the latest specifications, it's also type safe. So you can have type safe configuration being passed easily into your components without having to write any OSGi specific code. So the last, or not the last, but the next bit of complication is, okay, now we have lots of components, we have lots of configuration, we're using contracts for our APIs. We need a form of contract now to deal with the masses of configuration, or the amounts of configuration that we're dealing with. So we need some kind of schema that's going to validate the configurations for all of our components. And again, it's all about contracts. And so the next specification that we're heavily using is called metatype. And metatype is just that. It's a schema language for configuration. Lastly, we're typically building web applications. And what we mean by that is servlets, filters, listeners. And so we need support for this. And as of OSGi R6 specification, compendium specification, we have what's known as the HTTP Whiteboard spec. There was the HTTP service spec, which is still there and still useful, but the HTTP Whiteboard allows us to use the same services model that we've been talking about in order to build servlets and filters and all of these standard webby style traditional web programming model that we're familiar with. And it's actually a very refreshing way to compose complex applications together. If building web applications had been that composable from the beginning in Java EE, I don't think we would be talking about OSGi half as much as we are now. Fortunately, we are. And then lastly, the last important component that we need to deal with inside the lifecycle of our applications is tooling. And that's the IDEs and the builds and the CI. So it's fine to talk about all those other interesting technologies, but if we're not able to maintain them, then we don't really have a discussion. And today, since Maven and Gradle are the dominant tool chains, and Liferay was still building on Ant, and we were having a lot of pushback about that, we wanted to make a commitment to ensuring that building applications for Liferay would be as easy in your familiar Gradle or Maven world as it, or in as capable, as powerful as it would have been using Liferay's own SDK, which kind of shoehorned you in a particular model. And so now when you're building Liferay modules, which are just standard jar files, they're just OSGi bundles, you can use whatever tool chains you're familiar with, and we're providing more and more of our tools, more of the little built-in features as actual real Maven plugins and Gradle plugins for you to consume, Service Builder and all those things. And of course, Liferay is expanding its IDE, again, continuing to have better support for all of these new functionalities for Liferay IDE 3, which is going to support the functionalities of Liferay 7. And if you follow the talks today, this is going to get, all of this information is going to get more and more detailed. And finally, I just wanted to put a shout out to probably the largest project, which is pushing the boundaries of building proper modular software, and that is B&D and B&D tools. So whether you're using Ant and the Maven bundle plugin, or you're using Gradle and some OSGi plugin, if you are building OSGi anything, chances are, under the hood, it's using the B&D project, which is hosted by the bndtools.org, and it's an open source project, of which Tim Ward is a committer. So this is a very, very important piece of the ecosystem. And if you're unfamiliar with either one of these, the B&D is basically the underpinnings for creating OSGi bundles. It's the workhorse, and B&D Tools is an IDE built around that inside of Eclipse to build modular software using OSGi. So I strongly urge you to become at least familiar with these two projects, and if since they're open source, even just to get involved. And finally, Liferay, if you're not familiar, is a member of the OSGi Alliance, and as part of the OSGi Alliance, there's a mission to disseminate the OSGi principles. And one of the things that the OSGi Alliance is doing, is working on to do this, is a new project that was just launched this month called En route, which is an entire value chain of the best practices all the way to an IDE with plugins and workspaces and templates and tutorials and knowledge about how to build proper modular systems. And it even has support for Liferay. So I recommend you look at the En route project. If you're not familiar with building modular software, if you're just getting involved with OSGi, you can look at the En route project and quickly get started. It's probably the most ideal place to get started with building OSGi applications outside of the scope of Liferay. And then Liferay just bolts on top of this as far as deploying applications. So they work very well together. And that's it. And I have about 3 minutes or 4 minutes, and I just wanted to give people time to have, if they have questions for me. Yes.
Does the Liferay IDE 3.0 integrate with B&D tools?
Not as of yet, but it's something that we're considering. Yeah. But B&D Tools does have a launcher which can deploy its applications into Liferay, which is a very interesting concept, by the way. If you're not familiar with B&D Tools, it's probably the most innovative development that you will ever do. The really beautiful thing is that in your IDE, transparently, you can have the full life cycle of development seamlessly in the sense that as you're making code changes, it seamlessly redeploys your application to your runtime. And it can do this to Liferay as well. And this isn't in the fashion of JRebel, which actually uses class loader hacks on the JVM. This is real rebuilding of your jars and rebuilding of your modules and real redeployment, which actually puts your modules, your components at work to make sure that you've developed all the life cycle and all of the dependency models properly for unloading and reloading. So it's the most ideal way to develop OSGi applications. And it's really, really cool. Yeah.
How does the whole thing with the microservices integrate with my existing portlets?
So in Liferay 7, you can actually create portlets as microservices now. So what it would look like is a DS component. So basically, you would have a portlet class annotated with the declarative services annotations. You deploy that in a jar, and you can have all of the descriptor properties inside of your annotation. There's many, many examples that we can go through. It's quite an elegant model. The interesting thing with that, too, is that you get injected with real live dependencies. So it virtually eliminates the need for statics, such as like trying to get a Liferay service, right? Traditionally, you would go user local service util dot some method call, and then inside that there was the static wiring to some implementation. But now you could say, I have a dependency on user local service. I don't care about I'm not going to get statically wired. I'm not going to call the utility class. I'm just talking about the interface for that service. You get wired properly. We don't have to worry about any of these. It eliminates the statics, and now you're really getting injected. You really know whether the service is there and ready or not, and it's actually very, very refreshing.
Okay, the last question.
So since there aren't any, the next talks that we're going to, as we go through DEVCON, we're going to be talking more and more about the code. So you'll see this actually in practice, and there's a workshop later this afternoon that's actually going to go in detail. So thank you very much.
Thank you very much, Ray.
Thank you.